Okay, we're on Project C, Math 122. The expectation at this point is you know how to launch Sage, you know how to run a Jupyter notebook, and you know how to run it by the terminal. You know I'm going to be doing this by terminal though. All right, so this is a Sage project. And again, the intent here is that you listen to the video, but the bottom line is you got to stop at some point listening and start doing paper and pencil. And over here, it says over, typical Math 122 homework problem. And by when I say Math 122, if you're not taking 122, it's not a typical problem you'd have to see for a student to do. But in Math 122, you were given problems like this, and you were asked to evaluate it by using what's called a trigonometric substitution. It goes on to say, and I would typically tell students this, you'll need to complete the square first. A calculator should not be used to do the problem. And this is what I would expect most students to be able to do. Now, granted, you might look at it and say, oh, gee, well, I'm not going to look at that. I'm not going to pay any attention to that. You really need to study that. And you got to see the relationship between what you're learning in Math 122 and what's written up over here. But it's pretty straightforward. This is what I would probably do at the board if a student asked me to do this question over there. Now, granted, at the board, my penmanship wouldn't be as neat as the typeset work, but bottom line, this is what my work at the board would look like. All right? But I type it up, we get a final answer in the end, and we get this answer in the end for the problem. Now, I want to point out, a lot of times I'm often, confused when a student gives me their work, but I will be honest with this one student, Deborah Shanks. She not only got a different answer, but she showed some nice work to it. But I was kind of confused by the answer. I was saying, why does it look so different than my answer? And, it took me a little time to think through it, but I looked at her work, I thought through it, and I thought it was, a really nice job. I couldn't say anything bad about the job she did. But then the question comes is, I know that the antiderivatives, no matter what they look like, can only differ by a constant. So I was wondering why my antiderivative looks so different than hers. And let's go over what hers look like. Hers look like this one over here. I mean, it looks just so different to me. It looked really different. So what I had to do was, I had to look at the problem, and I had to determine, I said that they've got to differ by a constant. I just didn't know what the constant was. And also Deborah did the same thing. What Deborah did was she actually graphed it out and noticed that, my answer, her answer were just a vertical shift, a constant shift between the two, but she couldn't figure out the constant. And I'll be honest with you, I had to look at it and be careful about it. I did. I had to think about it. It took me time. I'll be honest with you. But what I want to do is I want to show that these things differ by a constant. All right? So what I did over here is I want to claim, this is me typing in code now, by the way. B stands for Bannon, by the way. This is my answer. And S stands for Shank, Deborah Shanks. All right? So what I want to do is I want to launch Sage. I want to claim that most students, if they're using Sage, it'll be in their doc. I'm going to launch a terminal application. By the way, if Sage is already running, it'll be running 2 instances of Sage. I'll show this right now. I'm actually running 2 instances of Sage here. I'm going to close this one out, exit, close the window. I'm done with that. And what I want to do is I want to start typing this code in over here. All right, reset. And I'm going to say X is a variable. And I'm sorry, I made a mistake already, didn't I? And I'm going to copy paste. And again, if you're wondering who types this stuff up, I type this stuff up. I don't think you should be copy pasting. I think you should be doing the code, looking at it, reading it, and trying to make sense out of it. All right? And let me get Deborah's in. And I'll put that down for you. And then what I want to do is I want to plot. And we'll take a look at it. By the way, you may wonder why I'm going between 0 and 4. That's the domain of the problem, between 0 and 4 only. All right, and I clearly see 2 graphs that differ by a constant. All right, it's a vertical shift. Now, the big question is how much should they differ? Now, some people are going to look at this and see if they can, get the number. I'm going to say you can approximate the number. I'm not saying you can't approximate the number. What I'm going to claim is I want to actually get the number. I want to get the number. or how they differ. So what I did over here was I just did a subtraction at S0 minus B0 to find out what the number is. All right, let me go through that with you. And I get 1/6. You know what? I want to approximate that number for you. That N there is an abbreviation for numerical approximation. And it's about 0.9 or almost like 1 unit difference between the two. That's how they differ. By the way, across the board, for example, if you did S1 minus B1, let's see what it gives you there. And it gives you the same result, all right? And you might say that's remarkable. Not really. It's not remarkable. We were expecting that. If we did our work right, we're expecting them to differ by a constant. I want to point out it's not easy to show they differ by that. Graphing is helpful, and noting that they both take on a maximum at 4 and a minimum at 0. For many, this may be overwhelming pre-calculus problem, but it nonetheless confirms what we know about the fundamental theorem of calculus, part 1 or part 2. All right, so that kind of closes it out. And again, I always value students that go the extra mile. In other words, neatly present their solutions. If they differ, they bring it to my attention for me to look at. All right, that is so important. If you present someone with really nice work, and all I did was I basically copied what Deborah did here, and it really bodes well when students put that kind of effort towards their studies. Thank you so much for paying attention.